Class 12th, Subject Physics, 13th chapter, AC Circuits. From this chapter, let us see numericals from exercise. Numericals from exercise. Let us see first of all numerical number 12, which is given as if the effective current in a 50 cycle AC circuit is 5 ampere, what is the peak value of current and what is the current 1 by 600 second after it was 0. And therefore for this numerical given data is frequency f equal to 50 hertz, current IRMS, that is RMS current, equal to 5 ampere, time interval t equal to 1 by 600 second, and we have to find out the peak value of current I0 and the instantaneous value of current I. Now the peak value of current I0 is given by the formula IRMS into root 2. I0 equal to IRMS into root 2, and therefore we can write I0 equal to 5 into 1.414. 5 into 1.414, which comes out to be 7.07 ampere. This is the peak value of current. Now the instantaneous value of current I is equal to I0 sine omega t, that is 2 pi ft, which will be equal to 7.07 sine 2 pi into 50 into 1 upon 600. But 2 into 50, that is 100, 100 upon 600, that is 1 by 6, and into pi, that is pi by 6. And therefore I will be equal to 7.07 sine pi by 6. But sine pi by 6 is half, and therefore 7.07 into half, which comes out to be 3.535 ampere. This is the value of instantaneous current. Now let us see next numerical, that is numerical number 13, which is given as a light bulb is rated 100 watt for 220 volt AC supply of 50 hertz. Calculate A, the resistance of the bulb, and B, the RMS current through the bulb. And therefore the given data for this numerical is power rated P is equal to 100 watt, then phi, that is phi RMS, equal to 220 volt, then frequency f is equal to 50 hertz. We have to find out resistance of the bulb R and RMS value through the bulb, that is IRMS. And therefore first of all we will find RMS value flowing through the bulb, that is RMS current through the bulb is given by the formula RMS current, that is IRMS, equal to P upon phi RMS. P upon phi RMS, putting the values we will get 100 upon 220, which comes out to be 0.4545 ampere. So this will be the RMS value of current flowing through the bulb. Now let us find the resistance of the bulb. The resistance of the bulb will be given by the formula R is equal to phi RMS upon IRMS. Putting the values we will get 220 upon 100 upon 220. So this 100 upon 220 is the value of this IRMS. Therefore we can write it as 220 into 220 upon 100. So that we will get here 484 into 10 raised to 2. This 100 will get cancelled with that 10 raised to 2, and we will get 484 ohm. 484 ohm, this will be the resistance of that bulb. And now let us go for next numerical, that is numerical number 14, which is given as a 15 microfarad capacitor is connected to a 220 volt 50 hertz source. Find the capacitive reactance and the current RMS as well as peak current in the circuit. If the frequency is doubled, what will happen to the capacitive reactance and the current? So for this numerical given data is capacitance C equal to 15 microfarad is equal to 15 into 10 raised to minus 6 farad. Then phi, that is phi RMS, equal to 220 volt. frequency f is equal to 50 Hertz, and we have to find out the capacitive reactance Xc, RMS value of current, that is IRMS, and peak value of current I0. So first of all, let us see the capacitive reactance is given as the capacitive reactance Xc is equal to 1 upon 2 pi Fc. Xc is equal to 1 upon 2 pi Fc. Putting the values, we will get Xc is equal to 1 upon 2 into 3.142 into 50 into 15 into 10 raised to minus 6. So putting these values, we will get here 10 raised to 4 upon 3.142 into 15, which comes out to be 212.2 ohm. 212.2 ohm, that will be the capacitive reactance. Now we will find RMS value of current, that is IRMS equal to Vrms upon Xc. Vrms upon Xc, that will be equal to 220 upon 212.2, which comes out to be 1.037 ampere. 1.037 ampere, that is the RMS value of current. Then we will find peak value of current, that is I0, will be equal to IRMS into root 2. IRMS into root 2, which comes out to be 1.037 into 1.414, and this product is 1.466 ampere. This will be the peak value of current. Then we will go for next numerical, that is numerical number 15, which is stated as an AC circuit consists of only an inductor of inductance 2 Henry if the current is represented by a sine wave of amplitude 0.25 ampere and frequency 60 Hz. Calculate the effective potential difference across the inductor. Take pi is equal to 3.142. And therefore for this numerical, given data is inductance L is equal to 2 Henry. Then peak current I0 will be equal to 0.25 ampere. Frequency f is equal to 60 Hz, and value of pi is 3.142. Then we have to find out the effective potential difference across that inductor. Effective potential difference, and therefore effective potential difference across the inductor will be given as omega L into IRMS. Omega L IRMS, and therefore the effective potential Phe will be equal to 2 pi FL into I0 by root 2. 2 pi FL into I0 by root 2, which comes out to be 2 into 3.142 into 60 into 2 into 0.25 upon 1.414. 2 into 3.142 into 60 into 2 into 0.25 upon 1.414. Simplifying this, we will get Phe equal to 754.1 into 0.25 upon 1.414. Solving this, we will get 133.3 volt. So 133.3 volt, this will be the effective potential difference across the inductor. Then we will go for next numerical, that is numerical number 16, which is stated as alternating EMF of E is equal to 220 sin 100 pi t is applied to a circuit containing an inductance of 1 by pi Henry. Then write an equation for the instantaneous current through the circuit. Then what will be the reading of the AC galvanometer connected in the circuit. And therefore for this numerical, given data is EMF is given, alternating EMF E is equal to 220 sin 100 pi t volt. So this will be the peak value, that is E0 of the EMF. Then inductance L is equal to 1 by pi Henry, and we have to write the equation of the current, that is equation of instantaneous current. as well as we will have to find out RMS value of current I RMS. And therefore, comparing the given equation E is equal to 220 sine 100 pi t with the standard equation of EMF E is equal to E0 sine omega t. So the given equation will be compared with the standard equation of EMF. Then we will get omega will be equal to 100 pi. So here 100 pi t will be equal to omega t, and therefore omega will be equal to 100 pi. Therefore omega L will be equal to 100 pi into 1 by pi, because L is equal to 1 by pi, and therefore we will get 100 ohm, that is the value of omega L. Then the instantaneous current will be given as I is equal to E0 upon omega L sine 100 pi t minus pi by 2, because here EMF and current both will be out of phase by a phase difference of pi by 2, and therefore here we can write E0 upon omega L sine 100 pi t minus pi by 2. That is I is equal to 220 upon 100 sine, then 100 pi t minus pi by 2, 100 pi t minus pi by 2, which comes out to be I is equal to 2.2 sine 100 pi t minus pi by 2, which is the required equation for instantaneous current. Then we can find the galvanometer reading, that is RMS value of current will be measured with the help of galvanometer, that is AC galvanometer, and therefore IRMS will be equal to I0 by root 2, that will be equal to I0 is 2.2 divided by 1.414, which comes out to be 1.556 ampere. 1.556 ampere, this will be the galvanometer reading. And then we will go for next numerical, that is numerical number 17, which is given as numerical number 17. A 25 microfarad capacitor and 0.10 Henry inductor and 25 ohm resistor. So here capacitor is having its capacity 25 microfarad, then inductor is having its inductance 0.10 Henry and resistance is 25 ohm. They are connected in series with an AC source whose EMF is given by E is equal to 310 sine 314 t in volt. Then what is the frequency, then reactance, impedance, current and phase angle of the circuit. And therefore for this numerical given data is C equal to 25 microfarad, that is equal to 25 into 10 raised to minus 6 farad. Then L is equal to 0.10 Henry, R is equal to 25 ohm, E is equal to 310 sine 314 t volt. Then we have to find frequency of inductive reactance XL, then impedance Z, then peak value of current I0 and RMS value of current I RMS, as well as phi is equal to question mark, that is all these quantities. So this will be the phase angle phi. Then now comparing the given equation of EMF, that is E is equal to 310 sine 314 t with the standard equation of EMF E is equal to E0 sine 2 pi ft, we will get F is equal to 314 upon 2 pi, because this will be omega, that is 314, omega is equal to 2 pi f, as 2 pi f is equal to 314, therefore f will be equal to 314 upon 2 pi, which comes out to be 314 upon 2 into 3.14, which is equal to 50 hertz. So this will be the value of frequency f, that is 50 hertz. Then we will find the inductive reactance XL. Inductive reactance XL is equal to omega L minus 1 upon omega C. omega L minus 1 upon omega C, which will be equal to 2 pi FL minus 1 upon 2 pi FC. 2 pi FL minus 1 upon 2 pi FC, that will be equal to XL is equal to 2 into 3.14 into 50 into 0.10. This will be the reactance minus 1 upon 2 into 3.14 into 50 into 25 into 10 raised to minus 6. So 2 pi FL, its value is this, 1 upon 2 pi FC is this, and therefore we will get XL is equal to 131.4 minus 127.4, which comes out to be 96 ohm. So the reactance will be equal to 96 ohm. Then we know that impedance, for impedance, Z square is equal to R square plus XL square. Z square is equal to R square plus XL square. Therefore Z square will be equal to 25 square plus 96 square, which comes out to be 9841, and therefore taking square root we can write Z is equal to square root of 9841, which comes out to be 99.2 ohm. 99.2 ohm, that will be the impedance of that circuit. Now the peak value of current, that is peak current I0 will be equal to E0 by Z. E0 by Z, that will be equal to 310 upon 99.2, 310 upon 99.2, which comes out to be 3.125 ampere. 3.125 ampere, that will be the value of peak current. Then we will find RMS value of current, which is given by IRMS equal to I0 by root 2. I0 by root 2, which will be equal to 3.125 divided by 1.414, which comes out to be 2.21 ampere. 2.21 ampere. This will be the RMS value of current. And now let us find the phase angle phi. Phase angle phi. For that purpose we are having the relation cos phi equal to R by Z. Cos phi equal to R by Z. From the phasor diagram, cos phi is equal to R by Z, that will be equal to 25 upon 99.2. 25 upon 99.2, which comes out to be 0.2520. 0.2520, it is the value of cos phi, and therefore we can write phi is equal to cos inverse of 0.2520. 0.2520, its cos inverse comes out to be 75.40 degree. 75.40 degree, which will be further converted in terms of radian as phi is equal to 1.316 radian. Phi is equal to 1.316 radian. This will be the required phase angle.